Okay, here we are with 4-4, day 2, working on those trig functions. And because we have all of the rules, we're just going right into examples today. So if you need your blue sheet handy, have that handy to refer back to them as I go through them. I'm not going to keep putting this up here. I'm just going to have it to the side of me. So it's just examples, nothing new today. Okay, when you see something like this, function p of x equals secant x times cotangent x. Your first instinct might be to go jump right into your product rule. But the rules are, if you see a couple of trig functions, you want to see if you can simplify them first before you jump into derivative. So we're going to simplify first. And then derivative after. This is that chapter 5 we did in trig last year. We had all of those trig properties. And one of our rules of simplifying was change everything to sines and cosines to see if anything will cancel out. So we're going to do that first. So this is not a derivative, it's still p of x. Secant, remember, is cosine flipped over. So you can rewrite that as 1 over cosine. And again, these are all in the back of your blue sheet if you need to look back. Cotangent, rewritten in sines and cosines, is cosine over sine. And then what we can simplify are the cosines. So cosines are gone. What we have is 1 over sine. And 1 over sine does simplify back to cosecant. So all I'm really going to do is take the derivative of cosecant. And the derivative of cosecant on my blue sheet is negative cosecant of the same angle times cotangent of the same angle times the derivative of the angle. The derivative of x is just a 1. Not that I would normally even write that down. So remember, simplify first, derivative second. And make sure your notation is correct. These are all still p of x and simplified. Right here is where we actually did the derivative. Try another. H of x equals 4 cosecant 3x times tangent 3x. So simplify first. Change everything to sines and cosines. See what happens. So the 4 stays. Cosecant is 1 over sine. Tangent is sine over cosine. The sines will cancel. We are left with 4 over cosine. Think of that as 4 times 1 over cosine. And 1 over cosine is secant. So what we have is 4 secant 3x. So now we're ready for derivative. Labeling it correctly. 4 is a multiplier. That's just going to carry along. When I look up secant's derivative, on the blue sheet, secant's derivative is secant of the angle times tangent of the angle times the derivative of the angle. The derivative of the angle is going to be 3. And then all I can do is float that 3 to the front for 12 secant 3x times tangent 3x. And number 3. Tangent 2x divided by sine 2x. Okay, so rewriting tangent in sines and cosines is sine over cosine. So it's sine 2x over cosine 2x, all divided by the sine of 2x that's down here. Well, think of this as a fraction divided by, if I put this over one another fraction, and I'll flip the bottom and multiply it by the top. So I'll have sine 2x over cosine 2x, that's the top, multiplied by the reciprocal of the bottom. I'll flip that over, I get 1 over sine 2x. Now I can see the simplifying is sines cancel out. I've got 1 over cosine. 1 over cosine is secant. But not yet. I still have not done the derivative, and I'm ready for that now. So y prime, derivative of secant right from the blue sheet, is secant of the angle times tangent of the angle times the derivative of the angle. And I just need to put that in the front. So 2 secant 2x, tangent 2x. So the whole point of these first three, if you see multiple trig functions going on in your problem, simplify first. Okay. Number 4. F of x equals 6 x to the 4th over sine x. Okay, there's not multiple trig functions in here, so I'm ready for derivative right off the bat. And what I've got is an x term divided by an x term, so that is a quotient rule. And if you follow your quotient rule, you need the derivative of the top, which is going to be 24 x cubed multiplied by the bottom, minus the top times the derivative of the bottom, all over bottom squared. And now, as far as simplifying, all we can do is factor the top. And what I have is a 24, there's two baskets. I've got a 24 and a 6, so I can take out a 6. X cubed and x to the 4th, we can take out the x cubed. Left inside is a 4. No x is left, so sine x. Minus, the 6 is gone, I'll still have an x. Cosine x. All over sine squared x. And if I look, there's nothing that'll cancel. So that's our final answer. Number 5. We've got y equals 3x times 1 plus tangent squared x. Okay. Even though there's not multiple trig functions here, this, because I've got a squared function with a plus or minus 1, remember our Pythagorean identities? And if you don't, they're on the back here. We always should check to see if we can simplify first. If we can't, we would just jump into product rule here. But this is an instance where I can simplify. And if you look at your quotient, the Pythagorean identities, we were looking for 1 plus tan squared. And if you look in the Pythagorean, number 3 here, 1 plus tan squared is secant squared. So I can simplify this by rewriting 1 plus tan squared as secant squared. And I'm going to write it with parentheses instead of by the function here. And now I am ready. I've done the simplifying, so now I'm ready for derivative. I've got an x term, which I'll call my u, multiplied by another x term, which will be my v. so we're going to follow the product rule here. And the product rule says, so now we're ready for derivatives, we're labeling it correctly. We take the derivative of the u term, which is a 3, multiply by the second term, which is secant squared, plus, keep the u term, multiply by the derivative of the v term. The v term is a chain rule, so it has an inside and an outside. So starting with the outside, the 2 comes down, times secant to the first power, and then times the inside derivative. Inside is the derivative of a secant. Looking at my blue sheet, secant's derivative is secant times tangent times the derivative of the angle. So, derivative of secant starts with secant times tangent times the derivative of the angle is a 1. I wouldn't need that. And now we're just going to simplify what we can. The first one's good to go. 3 secant squared. We can't do anything there. Here I've got a 1, a 2, and a 3 all multiplied. That's going to give me 6x. I've got a secant times another secant. That's going to give me a secant squared. And times a tangent. We could factor this. I'm not sure we have to or not. We'll have to check the answers to see if he's factoring or not, but we'll practice it. 2 baskets. We usually just factor if something's going to simplify out, but I don't think anything's going to here. We can take out, I see a 3 and a 6, we can take out a 3. And a secant squared. So if I take a 3 and a secant squared out of the first basket, it looks like there's nothing left there. But you do have to have that placeholder of 1 so that you could get it back if I distributed it back in. So when not everything's gone, there's still a 1 left in its place there. Here, I had a 6 and I divided out a 3. That leaves me with 2. Still have the x. All the secant squareds are out in front, leaves me with 10. Number 6. F of x equals the sine of sine x. Okay. The reason I'm doing this one is I don't want you to think this is a product rule. There is only one x term here. It's in the angle of this sine function. So this is truly just a trig function derivative, not a product rule. So it's the sine of this angle. So my outside function is the sine, my inside function is the angle. So we're ready for derivative. The derivative of sine is cosine. I have to have the exact same angle that had. So it's of sine x. Then I'm going to multiply by the derivative of the angle, and that's a trig function again. The derivative of sine, again, is cosine of this angle, times the derivative of the angle, which is a 1, which is not necessary. And there it is. There's no simplifying to be done there. All right, the last 2 are parts of problems from your assignment. Start on the page. Example 7 is number 41 from your homework that you're going to do today. We're just going to do the setup, and then I'm going to leave the problem for you. I'll show you the book real quick here.